Okay, Assalamualaikum and a very good day everyone. In this video, we are going to look at how to simulate the code while looking at the effect at the peripheral. Right, so before we do that, first of all, let's take a look at the values that we have in our coding. In this case, if you look at the values, so we play around with the location 2009C020 and also 2009C038. These two memory address. Okay, so if you realize these two memory address is related to the GPIO registers. Okay, and these two GPIO registers are actually related to the LED on our board. Okay, so let me just show you our board. Alright, so this is the board that we use, isn't it? Okay, so you can see that on this board we have these 4 LEDs. Okay, so if you have the board at the lab, so you can see physically the LEDs on the board. So the address that we played around in our code is actually related to the LEDs registers. Okay, so let me go back to our code. All right, so how to look at the effect of the code through simulation. Okay, so first click on peripherals, right, and then you have to refer to the schematic diagram of the board to look at the port related to the LED on board. So if you look at the schematic circuit, the LEDs are related to port 1 on the at the LPC1768 microcontroller. Alright, so because we had run the code just now, so this is the effect. Can you relate the effect over here? Okay, so when we store the values 00B4, 00002, 2009C020, okay, so at line 13 over here. So what we did is actually we are storing the value at the FIO1 DIR, okay, port 1 direction. So these 4 bits, 23 bits, this is bit 22, 21, 20, 18, and 19 and 18. So these 4 bits are all related to the LED on board. So we, from the DIR register over here, we are setting these 4 bits to become the output. Okay, because our LED is a digital output component, isn't it? So that's why we set the direction to the output. And the next line that we just correct just now, okay, which is store the R6, okay, store R6, which is 00040000 to R5, which is at location 2009C038. We are actually playing around with the register set, FIO1 set, in which we store the value 00040000 to our register FIO1 set. Okay, so I hope you can relate this value in hexadecimal to its binary values over here. Okay, so this is the binary related values with respect to the hexadecimal values shown in this space over here. Alright, so for example, the first digit over here in hexa 0 stands for 0000 in binary. Okay, and the next 4 bits over here is the next bit 0, 0, and then we have 0000, 4. Okay, 4 means 0100, isn't it? So that's why we have 0100. So the tick over here means 1. The value is 1. Alright, so if you I hope you understand this. Right, so if let's say we want to run the code one by one, so we can click on, just now we had already run it straight away, all the codes. You see the green colored one, all the codes being run until the end. So if let's say we want to restart the debug session, so we can click on reset. So when we click on reset, everything is being reset, okay, as you can see over here. And then what you can do is you can click the start icon over here for the lines to execute one by one. All right, and then you can see the effect one by one afterwards. Okay, so like we have line 1, sorry, line 9, okay, and then line 10. All right, so you can see 2009, and then the next one is we store we load we move the value into R4. Okay, so you can see afterwards R4 will be changing into 00B40000, and then the next one is we store the values inside R4 into the address point by R2, isn't it? So the address point by R2 stands for the address for FIO1 DIR register. So you will see afterwards there will be some changes to this site. Okay, at this peripheral window over here. So let's click on this. There you can see the difference now. So now FIO1DIR is being stored with 00B40000, and the binary representation of the data is shown here. Alright, so this is the binary bits where the one with tick is equals to 1. Okay, and the rest are 0. Okay, so same goes like this: 0, 0, 0, 0, 0, and this next 0 is 0, 0, 0, 0. B equals to 1, 0, 1, 1. Okay, B 4 equals to 0, 1, 0, 0. Right, and then if we run the codes again, so you can see that the next line, when we put store over here, so it will store the value 0004 0000 into this FIO1 set register. And later on, if you load this code inside your board, then you can see one of the LED will turn on. Why? Because we had put one bit over here to be set through this register. Alright, so if we recall this, so one of those will be turned on. So if that is the case, when you load the code inside the board, that it means that you had done the whole process correctly. Okay, so this is for GPIO simulation. Let me just take this opportunity to show you if, let's say, you are dealing with other peripherals. For example, remember we have this analog pin over here. So through simulation also we can see the effect at the analog pin. Okay, so how to do that? Once you write your code that has components connected to the ADC pin, then you can choose peripherals and choose this one, AD converter. Okay, so if you choose that, then you can see all the values or all the registers related to the ADC module. Alright, so this one you might need to use when you do your assignment, when you want to run the simulation wise. Okay, so I hope you can explore this for your assignment later on. Okay, everyone, I hope you enjoyed the lab session, and I hope everything will be smooth sailing for you. And if you have any question, you can always ask during our lab session. Okay, thank you for your attention. See you at the lab.